So we're going to look at how to find the area between curves. In a nutshell, if you need to find the area between a curve, you need to take the function that's higher up, or the sort of upper function, and then integrate that, and then take away the lower function. So if we look at what that might look like in notation, we'd say something like this. The integral from a to b of f of x dx minus the integral from a to b of g of x dx is going to give us the area between the curves f of x and g of x. So it'll help with an example here. So if we look at this function f of x equals sine x plus 1, which is in red, and g of x equals negative cos x plus 1 in blue, the first thing we need to do is we need to find where they intersect, because what we're going to try and find is this sort of shaded area in here. We want to know what the area of that is. So both of these functions have a domain just up to pi, and we're just interested in this shaded area here. So let's step through it. The first thing we need to know is where this point is, because we need to know where to integrate up to. So let's see what that looks like. So in order to find the intersection, you let the functions equal each other, and then you try and solve them. So subtract 1 from both sides, divide by cos x gives you tan, and then you think about your unit circle. Where does tan x, or for what values of x does tan equal negative 1? And hopefully you come to the conclusion that it's 3 pi on 4. And so what you can say is that this point here, the intersection point, must be at 3 pi on 4 and root 2 on 2. So that's the first thing. We need to know where this x value is at 3 pi on 4. Okay, so then what we can do is we can set up our integral. So we're going to take the integral from 0 to 3 pi on 4 of the upper function, which is f of x, minus the integral from 0 to 3 pi on 4 of the lower function, which is minus cos x plus 1 dx, when we integrate it. Okay, so that's our integral setup. Now we just need to compute some definite integrals, and this will get a bit messy, but we'll do our best. So the integral, or an antiderivative, of sine x plus 1 is minus cos x plus x between 0 and 3 pi on 4. And a similar situation here, the antiderivative of negative cos x is negative sine x plus x between 0 and 3 pi on 4. Okay, and then this is sort of up to you to sort of crunch the numbers. Basically, this first part will give you this. The second part will give you this, and remember, we need to take them away from one another. Okay, get out a pen and paper and crunch the numbers here, but a few things cancel out nicely. Like cosine of 0 is 1, becomes negative 1. This whole bracket here becomes 0. And yeah, you'll simplify to this. If you do a simplification, you'll get this situation, and then things can cancel out. This plus 3 pi on 4 minus 3 pi on 4 over here, so they're going to cancel out, and you're going to be left with 2 root 2 on 2 plus 1, and cancel the 2's out, you get root 2 plus 1, which is approximately 2.41. And so if we check the area of this sort of purple shaded region, it works out in our example here. Okay, so that's how you find the area between curves. You need to take the integral of the upper function between some point and the intersection between 2 points, and then subtract the integral between the same points of the lower function. One thing I wanted to point out here is we can also do one other thing. If we just for a second think about sine, letting them equal to each other and just rearranging it, so the ones would cancel out, we get sine x plus cos x equals 0. You'll notice that that's this orange line between 0 and 3 pi on 4, and you'll actually notice that's got the same area. So it's essentially doing the same thing. You're finding, to find the area between 0 and 3 pi on 4 of this function is the same as finding the area between sine x plus 1 and negative cos x plus 1. And I encourage you to think about why that might be the case. So something to think about. But hopefully that's an introduction and a nice example for finding the area between curves.